lesson 1.2. Today we're going to be classifying numbers, so putting them into different categories depending on their properties. And we like to classify numbers because each set of numbers kind of has its own little set of rules, and then we can talk about them more accurately. So let's have a look here at the Get Started. We're going to be writing each of these numbers as fractions, just for some extra practice, because fractions will kind of play a key part in today's lesson. So just as a reminder, if you have a whole number like 4, you can technically write that as a fraction. You would just put 1 in the denominator. 4 divided by 1 is 4, so that's 4 as a fraction. They're the same number. We wouldn't do that normally because it's just extra writing for no reason, but you can technically write 4 as a fraction. Same for negative numbers. You can put -6 over 1, and that would be a fraction. 0.7, so that's what we call a terminating decimal because the decimal stops, it doesn't keep going forever. And these can always be written as fractions. The little trick that you use is you count the number of numbers after the decimal. So in this case, that would just be 1. And so we would want to make this out of 0. If there were 2 numbers after the decimal, we would make it out of 100 with 2 zeros. If there were 3 numbers after the decimal, we'd use 1,000 with 3 zeros, etc. And then you just simply put the number on top, so 7. And with your calculator, you can always check if this is correct or not. Let me just clear this up here. So 7 divided by 10 is 0.7, right? So they're equivalent. 3.6, we're going to use the same little trick there. 3.6 would be 36 out of 10. 0.3 repeating, I'm not going to go into how, so this is called a repeating decimal. Another way to write this, that little line over top means the 3's go on forever. So it'd be like 3, 3, 3, 3, 3, 3, 3, 3. This is a very common repeating decimal, and it's equal to 1 over 3. 1 over 3 is the same as 0.3 repeating. If I typed 1 over 3 in my calculator, I would get 0.3 repeating. I'm not going to go over what the rules are for changing repeating decimals into fractions. You won't need to know how to do that. The only thing we need to know is that they can be written as fractions. I will post a video on how to do that though, if you are interested, but you won't be required to know. Okay, so fractions, remember I said, are kind of key for this lesson. So if a number can be written as a fraction, it's actually a special type of number. Not all numbers can be written as fractions. If a number can be written as a fraction, we call it a rational number. I'm going to use pink for rational numbers today. So we call it a rational number. So all the numbers in this pink box are rational numbers, and they can all be written as fractions. So notice any decimals there, they're going to be repeating decimals or terminating decimals, and all those square roots, we'll be able to answer those and write them as fractions. So let me just do a quick example. Square root of 4 over 9, if you recall from last lesson, that would be 2 over 3. And that's a fraction, so it's a rational number. If a number cannot be written as a fraction, we call it an irrational number, which is exactly the opposite of rational. So irrational numbers cannot be written as fractions. And that's definition of irrational. So all numbers that are real are either rational or irrational, one or the other. And I'm just going to write down the quick definition here. So rational numbers can be written as fractions, and irrational numbers cannot be written as fractions. Okay. If you're looking at a decimal, there's an easy way to tell if it can be written as a fraction or not. So decimal numbers, they will either be terminating, which means they stop. So like, for example, on that list there, 3.2 is a terminating decimal. It stops at 2, that doesn't keep going. So example 3.2. Okay, we also saw that above here in 0.7, that's a terminating decimal. It stops. Or it's a repeating decimal. It has a pattern and a repeating. So on that list there, we see 0.7 repeating. That can be written as a fraction. It's actually 7/9. Right. So that's how you tell if something can be written as a fraction or not, if you're looking at the decimal version of the number. Irrational numbers cannot be written as fractions. If you're looking at the decimal version of the number, it's not gonna repeat and it's not gonna have a pattern, and that decimal is gonna go on forever. So decimals go on forever with no pattern, no repeating pattern. So for example, square root of 2, that 2 is not a whole number, so there's nothing that multiplies twice to make 2. If I type that in my calculator, I'll get a decimal. And the decimal stops on the calculator just because there's not enough space to keep going, but it does repeat forever. So you could continue writing the numbers down. Same with pi here, the famous irrational number. Pi, as you recall, the decimals keep going forever. You can find someone's phone number in pi. You can find their birthday in pi because all possible combinations are within it. So I'll just write it down here, 1.414 ... 414 ... because it keeps going forever and there's no pattern. So there's actually no way to write square root of 2 as a fraction. Okay, so that's the main idea today, is categorizing numbers within one of these two groups. And then we're going to go a little bit further in this rational number category. Okay, so within the rational number category, there's actually 3 different special types, okay, and they're written right here. We've got natural numbers. Natural numbers are the first numbers you learn when you're a toddler. They're the numbers you would use to count on your fingers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on are all natural numbers. I guess we call them natural because they show up naturally. Whole numbers. Whole numbers are natural numbers, but then just one extra set. And I always remember this because the word whole has like a 0 or an O in it. So whole numbers are natural numbers, but they also include 0. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. Integers are whole numbers, but also include all the negatives. So no decimals in there, but negatives and positives and 0. I'm going to use purple for that. So integers, so like negative 24 would be an example of an integer. So not a decimal, but yeah. And rational number, we already talked about that. It can be written as a fraction. So all of these are rational numbers. These are all special types of rational numbers. There's actually a really nice picture on the next page. Let's head there now. This kind of shows everything all together and all the different names you have to know. So you have to know all these types in bold here, and you have to be able to categorize a number, which we'll practice doing in a second. So remember at the beginning we had rational numbers or irrational numbers. So a number is going to be in one of those two boxes. Either it can be written as a fraction or it cannot. That's what it says right here. It can be written as A over B, which means a fraction. And then within the rational number category, we have some special types. So we have natural numbers, which you first learn when you're a toddler, 1, 2, 3, 4, 5. Whole numbers, which include 0, and remember, you can remember that because of the 0 in whole or the O in whole. And then we've got our integers, which are negatives as well. Okay, so we're going to practice categorizing numbers now. So you have to be able to look at a number and decide which of these boxes it goes in. Okay. Sorry, I used blue here, and I should have used green. I'm picky when it comes to colors. There we go. Green, yellow, purple. Okay, because I want to use these colors when I categorize. Okay, so this check your understanding question it says classify each number. So it gives us a bunch of numbers, and then we have to decide which category it goes in. I'm not going to do every single one, but I'll go through at least like 6 or 7, and we'll do them together. Okay, so let's start with the first one on the list, 12. I'm going to use, there's not much room down here, so I'm going to use some of this blank space up here to do this work. Okay, so we'll start with the number of 12. So first thing you always want to do is decide, is this rational or irrational? Does it go in the pink box or the blue box? Because each number is one or the other of those. 12 is it can be written as a fraction. It's 12 over 1, so it would be a rational number. So it's in the pink box. If you're in that pink box, you could also possibly be these other special numbers, integer, whole number, or natural number. 12 is actually all of those. 12 is a natural number, it's a whole number, and it's an integer. There's no decimal associated with 12, so it's all of those things. It is an integer, it is a whole number, and it's also a natural number. So 12 is actually categorized, or it's in 4 of those boxes. It's an integer, it's a whole number, and it is also a natural number. Okay, let's look at the next one on the list. Square root of 8. So square root of 8. 8 is not a perfect square. When I take the square root of 8, there's nothing that multiplies twice to make 8. And so this is going to be a decimal that goes on forever and doesn't terminate. If I typed it in my calculator, I don't know why the calculator turns black after a while, but it does. If I type it in here, see, there's no pattern to that decimal. It's 828427125. So that decimal is going to go on forever. So we always want to decide, is it rational or irrational first? So in this case, it cannot be written as a fraction. So it's irrational. And once we've decided it's irrational, we can stop because there's no special terms within that group. So it's irrational, that's it. Okay, negative 9.12 is the next one on the list. So this is a decimal, but because it's terminated, it can be written as a fraction. If you want to write this number as a fraction, all you would do is, since there's 2 places after the decimal, we would make it out of 100 with 2 zeros. And we would just simply write negative 912 on top. So that is equivalent. So it can be written as a fraction. So it's not going to be in the blue box. It's going to be in the pink box. So this is a rational number. It can be written as a decimal, or sorry, as a fraction. But it's not an integer, a whole number, or a natural number, though, because it does have this decimal after it. And so that's all it is. It's just a rational number, but it's not an integer, whole number, or natural number. Okay, same with the next one. The next one is 24.35 repeating. Repeating decimals always can be written as fractions as well. So this is also a rational number, but because it has a decimal, it's not an integer, whole number, or natural number. So it's just simply a rational number. And that's it. Next one, negative 13. Okay, so remember, first thing we do, decide if it's rational or irrational. So negative 13 is the same as, so that can be written as a fraction, so it's a rational number. And it's also going to have another special categorization because it doesn't have a decimal after it. It is an integer. It's a negative number with no decimals. So that is classified as an integer. And it's not a whole number or a natural number, though, because those don't include negatives. So that's all it is. It's rational, and it's also an integer. Okay, we're going to do one more, and then after this, you can try the rest if you like. The answers are at the bottom there. We'll do cube root of 36. So cube root of 36, 36 is a perfect cube. There's nothing that multiplies 3 times to make 36. So if I type that in my calculator, it's going to give me a decimal that doesn't have a pattern and doesn't stop. So this is an irrational number. And you can always verify that on your calculator, but it's going to give you a decimal that goes on forever. Okay. And kind of make those same decisions as you go down and try them out for yourself. There's also another example here that the book has done you can go through if you need more practice categorizing. All right, so we're going to go to the next page now and look specifically at square roots and cube roots and determine if those are rational or not. What's a nice thing to do before you do these questions is kind of have your list of perfect squares and perfect cubes you can refer to. And that way it's going to be easier to tell if something can be written as a fraction or not. But we're going to go through each one of these and decide, is this a rational number or not? Okay, so, and I'm just going to make a little categorization box. You can draw this not if you want. So I'm just going to remind you, rational, irrational. I was using pink to describe rational and blue for irrational. Rational numbers can be written as fractions, irrational, not fractions. Okay, so let's look at the first one here, 0.0016. It's easiest to look at this one if you write it as a fraction. So you can use that little trick I mentioned before. Just count the numbers after the decimal. So 1, 2, 3, 4. So 0.0016 is out of 10,000 with 4 zeros. And we just simply put the number 16 on top. Okay, so if I was evaluating this, both 16 and 10,000 are perfect squares. 4 times 4 is 16, and 100 times 100 is 10,000. So I can evaluate this to 4 over 100, which is a fraction. And so this is a rational number. Okay, let's look at B, cube root of 42. So if I have a list of perfect cubes in front of me, I can tell 42 is not a perfect cube. There's nothing that multiplies 3 times to make 42. The closest one would be 27. 3 times 3 times 3 is 27, but you can't multiply 3 things to make 42. So this, if you typed in your calculator, it would give you a non-repeating, non-terminating decimal. So it would be irrational. So you should be able to categorize these numbers without a calculator, especially if you've got that list of perfect cubes and squares in front of you. Okay. 0.512, we can use that little trick again to turn that into a fraction. So that would be 512 over 1,000. Now I happen to know both 512 and 1,000 are perfect cubes. 8 times 8 times 8 is 512. And 10 times 10 times 10 is 1,000. So this works out nicely to a nice fractional answer. And so this is a rational number. And finally, the last one, if you want to pause here and try the last one on your own and then kind of check back, you can. Again, let's write that as a fraction so we can look at it a little bit closer. It'd be 1,006 over 1,000. Now 1,000 is a perfect cube, but 1,006 is not. Nothing multiplied 3 times makes 1,006. And so this is irrational. There we go. Okay, so that's how to categorize numbers as rational or irrational, even if you don't have a calculator. Okay, and that's basically the end of the lesson. The key idea here is you want to be able to categorize and put numbers into the pink or the blue box. And then if it's in the pink box, you'll have to be able to go further and decide if it's an integer, a whole number, or a natural number. All right, I'm going to pause this.